All right, on to page 3. We're going to start with problem number 3, which says to write each exponential equation as a logarithmic equation. So I'm going to zoom in on part A here. First thing I want to do is find my base, because that is going to be the base of the logarithm. So it's going to be log base 3. Now you got to figure out what goes where. Now I'm going to tell you that the logarithm is equal to the exponent, so that means the argument is going to be what the exponent was equal to. So log base 3 of 27 equals x. That is the transformed version. Now, one thing to be very careful about with these, when you are writing a logarithm, make sure that the base is a subscript so that you can tell the difference and I can tell the difference between what the log is, what the argument is, what the base is. All right, let's slide over to part B here. Find your base. Now this one is a little bit trickier, but the base is whatever is attached to the exponent. In this case, the exponent is x, and what's attached to it is 1/3. So we're going to do log base 1/3 of 27 equals x. Remember, the logarithm is equal to the exponent, whatever the exponent happens to be. All right, problem part C. I'm going to find the base. Base is 2 here. So this is going to be log base 2 of x is equal to 7. So the argument of the logarithm is what the exponential function is equal to, and the exponent is what the logarithm is equal to. All right, and part D, and this will be the end of this particular problem, find the base. Well, the base here is 27 over 3. You could reduce that if you wanted to. I'm just going to leave it as is. So this is going to be log base 27 over 3 of 5/9 is equal to x. So lots of weird stuff going on with that problem, but it is what it is for part D with those fractions in there. All right, now number 4, we're going to reverse the process, right? We've got logarithmic equations. We're going to rewrite them as exponential. So I'm going to find the base. My base is 3. So this is going to be 3 to the power. And remember, the exponent is what the logarithm is equal to. So 3 to the 8th is equal to the argument of 6,561. All right, so that is part A done. I'm going to slide over to part B. Part B, I'm going to find my base. My base is, in this case, 5/9. So we're going to do 5/9 to the 4th power is equal to x. So the logarithm, remember, is equal to an exponent. So there's the exponent. The argument is equal to the answer of the exponential function. And just for giggles, I'll go ahead and throw the box around it so you know it's done. All right, part C here, find the base. Houston, we got a problem. There is no base written here, so we get to make an assumption. Now, we don't get to make up our own base. There is a base that we assume when there isn't one written here, and that is the base 10. So this is going to be 10 to the x is equal to 4. That's the rewrite for part C, okay? So let's slide on over to part D. Part D, find the base. We don't have a base here either. However, part D is not a regular log. It's not the common log that you just write log. This is the natural log, and natural logs only have one base, and that's the letter E. So this is e to the 6th is equal to x. All right, so when you see ln, or natural log, that's a base E. If you see, let me slide over, if you see just log, so log by itself, that is a base 10, okay? All right, so problem number 4 is all done with rewriting the exponential as logarithmic, logarithmic as exponential. Problem number 5, which is, I believe, the last problem on this page, we have a logarithmic function graphed, f of x, and we are supposed to label and graph k of x, which has a few changes to it. So first change here, I'm going to zoom in here. We've got the -1 attached to x, and we have a -4 attached to the function. Each one of those is its own transformation. So I'm actually going to do the transformation part first, and then I will use the transformations to draw the graph. So this little part in purple here, which is directly attached to x, that is a horizontal translation, and that's going to be to the right 1. And then you have this -4 at the end, right? The whole function's being affected by that. So that's a vertical translation. And it's negative, so that's going to be down 4. Okay? So every point on my graph, I am going to move to the right 1 and down 4 spaces. So I've got these. Sorry about that. Wow, I'm just having all kinds of issues here with stuff. Sorry about that. So each one of these points is moving right 1, down 4, right 1, down 4. So let's go ahead and graph those up. I will go with purple here, I guess. So let's see. Right 1, 1, 2, 3, 4. Right 1, 1, 2, 3, 4. Right 1. And this one, be careful with this point since it's not quite on a grid line. When you count it out, just be careful that you keep it off the grid lines. 1, 2, 3, and 4. Now, I'm going to give you a hint here. All right, kind of a big, huge hint. The logarithmic functions have vertical asymptotes. We talked about this in the first couple of problems. Your vertical asymptote is going to be, in the original problem, right here on the y-axis. Okay? But we've moved our graph. We have shifted it. Now, the horizontal shift is the one that matters. Shifting down, it doesn't matter. You could shift down or up, and that won't change that vertical asymptote. But shifting to the right 1 means that we're going to take this asymptote, I looped it so I can move it, and I'm going to move it to the right 1 unit. The reason I think it's important to do that is when you now go to graph these 3 points and actually play connect the dots here, I cannot cross this pink asymptote. I can get really close to it, but I can't cross it. So when I go to make my curve here, I'm going to go through the 3 points I've got, right? Curve up and to the right. And then this bottom part, I'm just getting closer and closer to the pink asymptote without ever touching it or crossing it. All right. So just maybe use that as a guide to help you when you are trying to change that graph. Make sure you put the asymptote in there, because if your graph ends up going, through these 3 points and way over here, I will knock points off of that because that's not how the graph looks. Okay, so when you have the curve to use as an example, right, you can see the curve right here, use it as the example. All right, so that's the end of page 3. Let me know if you have any questions or concerns.